Okay, this is the basic property of equations in algebra. It's the addition property of equality, and you can see that on page 4. And the addition property of equality, let's go ahead and write that, E-Q-U-A-L-I-T-Y, equality. The property of equality is that if you have A is equal to B, then, so this is kind of an if-then statement. I'm going quickly because I cannot keep this thing under 10 minutes. If A is equal to B, then A plus C is the same as B plus C. And let's throw some numbers in here. Say A and B are both 4. Okay, 4 is equal to 4. That makes sense. And if 4 is equal to 4, then 4, because A is 4, plus, let's let C equal 2, is the same as 4 plus 2. See, if 4 plus 2 is 6, and 4 plus 2 is 6, then 6 is equal to 6. This sounds kind of complicated, but it's going to make sense. We can do the same thing with subtraction and with addition. And let me just show you an example. Say we have x minus 7, and we set that equal to 6. Now we don't know what x is, but I'm going to add 7 to both sides. Okay, and x minus 7 plus 7, negative 7 and positive 7 equals 0. And so we just have an x left. Okay, and that is equal to 6 plus 7, which is 13. And then if I put that back in the equation, the original equation, if x is equal to 13, and I rewrite that, x is 13. I just said that. So let's rewrite that like this equation right here. 13 is what the x is, minus 7 is equal to 6. 13 minus 7, put a little 13 right here by this x. 13 minus 7 is equal to 6. Hopefully that makes sense. I'm going awfully fast. Let me show you the, make sure you're paying attention. This is a teeter-totter. Now, I know we don't have one of these in our playground. Well, maybe you do, but I don't. And a teeter-totter has this little balanced. And if you put the same amount of weight on each side, it stays balanced. So that's what an equation is like. It's a balanced thing. And so we have that same equation, x minus 7 is equal to 6. Okay, so this is the same as this because they're equal. The equal sign in an equation helps us understand that. So say we have all of these things, and if I want to add 7 to it, then this side would get heavier. So I have to add 7 to this side as well, right? And so as long as I do something to both sides, as long as I do the same amount, I put the same amount on, or I take the same amount off, I should still have a balanced equation, and my teeter-totter will stay level. Okay, so I've added 7 to both sides. And I just want you to remember, we already did this, but it's just to help us remind ourselves. A negative 7 and a positive 7 end up being 0. So x is on the teeter-totter all by itself on this side now. Okay, x is all by itself, but now 7 plus 6 is 13. And it's still balanced, but x is 13. And we just did that. But the teeter-totter helps us understand what happens, but it's something we just have to kind of work with until we can kind of make sense of it. They're going to throw strange decimal numbers and things at you. Y plus 3.4 is equal to 0.5. And then you do the opposite. You kind of imagine the teeter-totter, and I have a positive 3.4. I want to solve for y. I want to get that by itself. Okay, so I want that lonely y on one side of the teeter-totter all by itself. So to get that, I'm going to subtract 3.4 because 3.4 minus 3.4 is 0. That leaves the y all by itself. But I have to do it to both sides or it doesn't work. Okay, and what happens when I take 0.5 and I subtract 3.4? Well, when you have a positive number and a negative number, you can really take the 3.4, put it on top, subtract 0.5. You take the larger number. See, now this is farther in the negative direction, so it's not really a larger number. But if you were to get rid of this negative sign, it would be. And we just subtract them. 4 take away 5, you have to borrow there. 14 is 9. And 2 take away 0 is 2, and it's 2.9, and then you just keep the sign of whichever one of these is bigger. Negative 3.4, 3.4 is bigger, so we're going to keep the negative sign. Okay, now that's a whole nother lesson. I hope you guys already know how to do this. I'm worried it's the very beginning of the book that you might not know how to do that. Let me show you a couple of quick examples. 7, I have a 7, and I have a minus 2. Well, you know how to do that. What if I had the negative 2 plus 5? And I wanted to just figure out what to do with this. Well, I take the bigger number, and just looking at the number, not looking at the sign, and I subtract them. And I get 5 take away 2 is 3. And since there's more positive than negative, I'm going to keep a positive 3. Now, we could go on all day with these. If they're the same, that's maybe a bad example. 3 plus 5. That becomes 8. You know that. But what if I throw a negative sign in? Negative 3 plus 5. Well, I have a positive 5 and I have a negative 3. And since I have one positive and one negative, I'm just going to subtract them. I'll start with a big number and get 2. And then figure, since there's more positive than negative, it's a positive 2. What if it was the other way around? What if it was a positive 3 and a minus 5? I wrote 2. There we go. And a minus 5. Well, I'm still going to do 5 minus 3, just like I did up here. This time, though, when I get my 2, since the 5 is more negative than the 3, I'm going to keep the negative sign. So 5 and negative 3 plus 5 is plus 2, and 3 minus 5 is negative 2. The other way to do that is to just look at a number line and compare them. Okay, if I have negative 3, I have to switch back to my other tool. Negative 3 plus 5. I'm going to start at negative 3, and I'm going to move forward in a positive direction 5. It's kind of like jumping. 2, 3, 4, 5. This is where I land, and I have, that's a 2. So the number line is kind of neat. It kind of makes it work out nicely. Okay, enough of that. We'll keep moving. This next example is solving using multiplication and division, and it's the same thing. It's just like the teeter-totter. You have to keep it balanced. I'll go ahead and write a little teeter-totter just for practice sake, and then we'll look at the first one here. They give us negative 3/4 n, and then it's equal to negative 2. So this might look like, if you were just looking at a regular equation, 3/4 n is equal to 2. See, now this is really what we're looking at is 3/4, negative 3/4, times n equals a negative 2. And I can divide by 3/4. Since it's times n, I can divide by 3/4. But really, when you divide fractions, you multiply by the reciprocal. And the reciprocal here is 4/3. And then I have to multiply by 4/3 over here. Make sure it's a negative 4/3. And then I want to also put that over a 1 just so I can see it. Now, those of you that remember, the 3's cancel, the 4's cancel, and the negatives cancel, and so it becomes a positive n. And negative 2 times negative 4 is positive 8, and 1 times 3 is 3. So you should get 8/3, and if you remember your fractions really well, 8/3 is also the same as 2 and 2/3, and that should be the answer. Oh, it looks like the book left it in a fraction, an improper fraction form. So they had this as their answer, not 2 and 2/3, although those should be the same. Okay, let's do one more quick one. They use pi just to throw you off. Pi times x equals 3 times pi. Now this time I want to solve for the x. The x is the one I want to get by itself, and you could be confused by the pi. But I'm going to divide. This is pi times x, so I'm going to divide both sides by pi. And pi over pi is the same as 1. Just like 5 over 5 is equal to 1, pi over pi is equal to 1. That leaves x all by itself. And then these pi's also cancel out and equal 1, and it leaves you with 3. So pi is equal to 3. And that's kind of neat. If you could stick it back in there in the original equation, pi times 3 is equal to 3 times pi, and you could kind of see why that would be true. Okay, very good. That should do your whole lesson. I can help you with this. I know this is probably going to take some work, but we'll get to it. And if you are completely lost on fractions, we're going to have to back up and do something else. But I think you guys got it.